Good day, everyone. So for today, we're going to discuss about finding the vertical and horizontal asymptote of a given rational function. In finding the vertical asymptote of a given rational function, remember that it is the restrictions on the x values of a reduced rational function. To find the restrictions, we must equate the denominator to 0 and then we're going to solve for the value of our x. In finding the horizontal asymptote of a given rational function, we let n be the degree of the numerator and m be the degree of denominator. So let's say if the degree of the numerator is less than the degree of the denominator, therefore, the horizontal asymptote of a given rational function is equals to 0. Then, if the degree of the numerator is equals to the degree of the denominator, we're going to use the form y is equals to a over b, wherein a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. And if the degree of the numerator is greater than the degree of the denominator, it is said that there is no horizontal asymptote of a given rational function. Okay, class, so before we proceed into our lesson in finding the vertical and horizontal asymptote of a given rational function, let us have short review about the degree of polynomial. We're going to use the concept of degree of polynomial in finding the horizontal asymptote of a given rational function. Remember that when we say degree of polynomial, it is the highest exponent in a given expression or polynomial. For example, we're going to find the degree of polynomial of the following given expression, 4x. So the degree of polynomial of 4x is 1, since we all know that if there is no written exponent, therefore the exponent is 1. Next, x minus 4. It is also 1. Next, 2x to the power of 3 minus 4x plus 6. So the highest exponent is 3. So therefore, the degree of polynomial is 3. 7. So since our given is a constant term, so therefore, the degree of polynomial is 0. Okay, class, so let's proceed into our lesson for today, wherein we're going to find the vertical and horizontal asymptote of the given rational functions. For example, we let f of x is equals to 3 over x plus 4. Remember that in finding the vertical asymptote of a given, we're going to equate with 0. So you have x plus 4 is equals to 0. So therefore, you have x is equals to negative 4. So the vertical asymptote is x is equals to 4. Next, find the horizontal asymptote of the given. In finding the horizontal asymptote, remember to look for the degree of polynomial of our numerator and in our denominator. So the degree of our numerator is 0, while the degree of our denominator is 1. So it is said that if the degree of our numerator is less than the degree of our denominator, so therefore the horizontal asymptote is equals to 0. So y is equals to 0. Okay, class, let us have another example. So we let f of x is equals to 4x minus 2 over x plus 2. Let us have first the vertical asymptote of our given. So remember, in finding the vertical asymptote, we need to equate our denominator to 0. So you have x plus 2 is equals to 0. So we have x is equals to negative 2. So therefore, the vertical asymptote is equals to x is equals to negative 2. Next, let us find for the horizontal asymptote of our given. So you look first for the degree of our numerator and the degree of our denominator. So the degree of our numerator is 1 and the degree of our denominator is also 1. So therefore, we're going to use y is equals to a over b, wherein a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So you have y is equals to 4 over 1. So therefore, the horizontal asymptote is y is equals to 4. Okay, class, let us have another example. F of x is equals to 6 over x squared minus 36. In finding for the vertical asymptote, we need to equate our denominator to 0. So you have x squared minus 36 is equals to 0. We all know that x squared minus 36 can be factored. So you have x minus 6 times x plus 6 is equals to 0. So therefore, x is equals to 6 and x is equals to negative 6. So therefore, the vertical asymptotes of our given are x is equals to 6 and x is equals to negative 36. Next, we look for the horizontal asymptote of our given. So look for the degree of our numerator and our denominator. So the degree of our numerator is 0 and the degree of our denominator is 2. So you have now the degree of our numerator is less than the degree of our denominator. So therefore, y is equals to 0. So the horizontal asymptote of our given is y is equals to 0. Okay, let us have another example. We let f of x is equals to x squared minus x minus 6 over x minus 3. So we need to equate our denominator with 0 to find for the vertical asymptote of our given. So you have x minus 3 is equals to 0. So you have x is equals to 3. So therefore, the vertical asymptote of our given is x is equals to 3. Now, we're going to look for the horizontal asymptote of our given. So, look for the degree of our numerator and the degree of our denominator. And as you noticed, the degree of our numerator is greater than the degree of our denominator. So, it is said that in that case, the horizontal asymptote is none, or there is no horizontal asymptote of our given. Okay, class. So after discussing about finding the vertical and horizontal asymptote of a given rational function, so now we're going to discuss about finding the x and y intercepts of a rational function. So when we say intercepts, these are the x or y coordinates of the points at which a graph crosses the x-axis or the y-axis respectively. Okay, class. So for example, we're going to find for the x and y intercepts of the given rational function. So it is said that in finding the y-intercept, we need to substitute 0 for x and solve for y or the f of x. While if we're going to find the x-intercept, we need to substitute 0 for y and then solve for x. So for example, we have f of x is equals to x plus 4 over x minus 2. So in finding for our y-intercept, so we need to have f of 0 is equals to 0 plus 4 over 0 minus 2. And then, since we have 0 plus 4, that is 4, and 0 minus 2, and that is negative 2. And then divide 4 and negative 2, so we have negative 2. So therefore, y-intercept is y is equals to negative 2. And also, to easily find for the y-intercept, remember that it is the quotient of the constant terms. Next, let us find for the x-intercept. We let 0 is equals to x plus 4 over x minus 2. So we have 0 is equals to x plus 4. And x is equals to negative 4. So therefore, the x-intercept is x is equals to negative. Let us have another example in finding the x and y intercept of a given function. So we let f of x is equals to x squared plus 5x plus 4 over x squared minus 2x minus 3. So we all know that we can factor both numerator and denominator. So we have x plus 4 times x plus 1 over x minus 3 times x plus 1. And you will notice that we can cancel x plus 1. So therefore, we have x plus 4 over x minus 3. And then, we need to substitute 0 for our x to find for the y-intercept. So you have 0 plus 4 over 0 minus 3. So you have 4 over negative 3. So therefore, the y-intercept is y is equals to negative 4 over 3. Remember that the y-intercept is the quotient of the constant term. Next, find for the x-intercept. In this case, we need to equate y into 0. So you have 0 is equals to x plus 4 over x minus 3. And then you have cross multiplication. That's why we have 0 is equals to x plus 4. Then x plus 4 is equals to 0. So x is equals to negative 4. So therefore, the x-intercept is x is equals to negative. Okay, class. So that would be all for today, discussing about finding the vertical and horizontal asymptote of a given function and the x and y intercept of a rational function. So again, thank you for listening and Laus Deo.